Picture this. You hold a single grain of sand between your fingers. Smooth, barely visible, weighing almost nothing. Now imagine that this tiny speck represents our entire Earth. Every mountain, every ocean, every life that has ever existed compressed into that microscopic fragment. If Earth is that grain of sand, then the observable universe would be larger than the actual Earth you're standing on right now. Not a building, not a city, not a continent, the entire planet. Your brain just broke a little, didn't it? But here's what's truly terrifying. That comparison isn't even close to capturing the full horror of cosmic scale, because while you were trying to process that impossible ratio, the universe got bigger and bigger and bigger still. Every second you've been alive, space itself has been stretching, carrying distant galaxies away from us at speeds that would make light itself weep in defeat. Some regions of space are now racing away from us faster than light can travel, which means they might as well not exist at all. They are forever lost to us, sealed behind an expanding horizon of impossibility. This creates the most claustrophobic paradox in existence. We live in an infinite universe that is simultaneously a prison 99.999. 9% of everything that exists will never be touched by human hands, seen by human eyes, or known by human minds. We are cosmically quarantined on a spinning rock, watching the universe grow larger and more unreachable every moment, like cosmic castaways on an island that shrinks while the ocean expands forever. Why? Why did reality choose this path? Why is space so incomprehensibly, suffocatingly, devastatingly big? The easy answer is that space simply is big, the way water is wet or fire is hot. A brute fact requiring no explanation. But that answer is a lie, or at least a surrender, because the universe didn't have to be this way. In the first moments after the Big Bang, space could have remained small, intimate, knowable. Instead, something chose infinity over coziness, vastness over human comprehension. Something chose to make us feel small. Consider the violence of this choice. Right now, as you sit reading this, you are moving through space at speeds that should terrify you. Earth spins at over 1,000 miles per hour at the equator. We orbit the sun at 67,000 miles per hour. Our entire solar system hurtles around the galactic center at 514,000 miles per hour. And our galaxy itself races through the cosmic void at over 1,000,000 miles per hour, toward some unknown destination. You are not sitting still. You are screaming through an abyss so vast that our fastest spacecraft, Voyager 1, launched in 1977, has barely begun to scratch the surface of our own solar system's edge. Yet for all this motion, for all this cosmic violence, when you look up at the night sky, the stars appear fixed, eternal, peaceful. This, Maeve, is space mocking us with its enormity. The distances are so vast that even our breakneck journey through the cosmos registers as stillness. We are moving incredibly fast through something so big that we might as well be motionless. But the true existential horror isn't just that space is big It's that space is actively becoming bigger, and there's nothing we can do about it. Dark energy, that mysterious force that makes up 70% of everything that exists, is pushing the universe apart like an invisible hand stretching reality beyond recognition. Galaxies we can see today will eventually vanish beyond the cosmic horizon, their light red-shifted into oblivion. Future civilizations will inherit a lonelier universe than ours, and their descendants will inherit one lonelier still, until finally, in the deep future, any remaining consciousness will find itself alone in an expanding bubble of darkness, surrounded by nothing but the cosmic microwave background radiation, the fading echo of creation itself. This expansion isn't random. It's accelerating. Space isn't just getting bigger. It's getting bigger, faster. The universe is running away from itself with increasing urgency, as if reality is trying to escape something, or perhaps it's trying to make room for something so vast that even infinity isn't enough space. Yet here's the paradox that should keep you awake at night. Despite all this cosmic vastness, despite the universe's apparent indifference to human scale, you exist, against odds so astronomical that mathematicians run out of words to describe them. Matter organized itself into complexity. Complexity organized itself into life, and life organized itself into consciousness, capable of contemplating its own cosmic insignificance. The universe became so large that it could contain something so small that it could wonder why. Perhaps that's the first clue. Perhaps the universe didn't choose to be incomprehensibly vast despite us, but because of us. Perhaps consciousness requires an arena so vast that it can contemplate infinity without breaking. Perhaps the universe had to become unimaginably large so that something unimaginably small, a thought, a dream, a moment of wonder, could recognize itself against the backdrop of eternity. By the end of this journey, you'll understand why the universe had to be this big, and why that reveals the most profound secret about existence itself. But first, we need to travel deeper into the abyss of scale, where human intuition goes to die and cosmic truth begins. The universe is not just big. It's big for a reason, and that reason will change everything you think you know about why you exist at all. We are prisoners of our own evolution, trapped inside brains designed for a world measured in footsteps and heartbeats. For millions of years, our ancestors navigated landscapes where the farthest meaningful distance was the horizon, perhaps 20 miles on a clear day from a high hill. Anything beyond that simply didn't matter for survival. You couldn't hunt it, gather it, fight it, or mate with it. So natural selection carved neural pathways optimized for human scale, creating minds exquisitely calibrated for distances you could walk in a day and objects you could hold in your hands. This is why you can effortlessly estimate whether a coffee cup is 6 inches or 6 feet away, but your brain turns to mush when confronted with 6 million light years. Your visual cortex, refined across eons of dodging predators and finding food, can instantly calculate the arc of a thrown spear or judge whether you can leap across a stream. But show that same brain the distance to the nearest star, and it might as well be trying to taste the color purple. The machinery simply isn't there. Consider this. You know, intellectually, that the moon is roughly 240,000 miles away. You've memorized this number. perhaps even used it in calculations. But you don't feel it. The moon looks like a dinner plate hanging in the sky, close enough to touch if you climbed a tall enough ladder. Your brain insists the moon is maybe a few miles up, despite every fact you know to the contrary. This isn't ignorance. It's the fundamental limitation of consciousness evolved for terrestrial distances. Now attempt to grasp that our nearest stellar neighbor, Proxima Centauri, sits 4.2 light-years away. That's roughly 25 trillion miles. But what does that number actually mean to a brain that thinks 1,000 miles is very far indeed? Let's try to build some intuition. If you started walking toward Proxima Centauri at the moment of your birth, maintaining a steady pace of 3 miles per hour for 12 hours every day, you would die of old age. Your children would die of old age. Your great-great-great-great-grandchildren would die of old age. In fact, your bloodline could continue for 900 million years, long enough for complex life to evolve from scratch on Earth. And your descendants still wouldn't be even 1% of the way there. The speed of light itself, that ultimate cosmic speed limit, takes 4.8 TDWR to traverse this nearby distance. Light, which can circle Earth's equator 7 times in a single second, crawls across interstellar space like a cosmic snail. If the sun suddenly vanished, we wouldn't know for 8 minutes, the time it takes sunlight to reach us. But if Proxima Centauri exploded in a spectacular supernova tonight, we wouldn't see the fireworks until 2029. The stars you see when you look up aren't showing you the universe as it is, but as it was years, decades, centuries ago. Yet Proxima Centauri is essentially in our cosmic backyard. Our galaxy contains roughly 400 billion stars, most separated by distances that make the journey to Proxima seem like a pleasant afternoon stroll. The Milky Way stretches 100,000 light-years from edge to edge. If you could somehow travel at the speed of light, the fastest anything can possibly move through space, it would take you 100,000 years to cross our galaxy. Entire civilizations could rise and fall in the time it takes light to journey from one side of the Milky Way to the other. But what if our inability to grasp cosmic scale isn't a bug? It's a feature. This limitation feels like cosmic cruelty, but perhaps it's cosmic mercy. Your brain's inability to truly comprehend vast distances might be the only thing standing between you and complete psychological breakdown. Imagine if you could actually feel the 25 trillion miles to Proxima Centauri the way you feel the distance to your kitchen. Imagine if your nervous system registered the true scale of galactic distances with the same visceral immediacy it uses to warn you about an approaching car. You would be paralyzed by the overwhelming vastness, crushed under the weight of distances so enormous that they make human existence feel like a rounding error in the cosmic accounting. Evolution has given us a kind of scale blindness for the same reason it gave us psychological mechanisms to cope with mortality. If we truly, deeply, viscerally understood how tiny and temporary we are, we would be unable to function. We would curl up in corners and weep at the magnificent futility of it all. Instead, our brains compress the incomprehensible into the manageable, turning trillion-mile distances into abstract numbers that we can manipulate without feeling their weight. This compression creates profound distortions in how we perceive reality. Most people can conceptualize 1 million of something, $1 million, 1 million people, 1 million grains of sand. You can imagine a large stadium filled with 1 million spectators. Or visualize what 1,000,000 pennies might look like spread across a field. But 1,000,000,000? 1,000,000,000,000? These numbers become meaningless sounds our mouths make, empty syllables disconnected from any experiential reality. The difference between 1,000,000 and 1,000,000,000 is the difference between 11 days and 31 years. The difference between 1,000,000,000 and 1,000,000,000,000 is the difference between 31 years and 31,000 years. Yet in our minds, they occupy roughly similar spaces. They're all just very big numbers, somewhere beyond the reach of intuition. We treat a light year like an upgraded mile, when it's actually the distance light travels in 365 days of continuous motion at 186,000 miles per second. It's not a longer mile. It's a fundamentally different kind of distance altogether, belonging to realms of space that operate by rules our terrestrial experience never prepared us to understand. This cognitive blindness extends beyond mere distance to encompass time, mass, energy, and probability. You might know that the universe is 13.8 billion years old, but you can't feel that duration any more than you can feel the distance to Andromeda. Your brain, calibrated for lifetimes measured in decades, treats geological time, evolutionary time, and cosmic time as mere variations on a very long time ago. The difference between 1,000,000 years and 1,000,000,000 years, the difference between the recent evolution of human consciousness and the emergence of complex life itself, collapses into the same psychological category of ancient. Yet here's where the real paradox emerges. Despite our inability to grasp cosmic scale, we have somehow managed to measure it. Using tools and mathematics, abstract reasoning and collective intelligence, we have mapped distances that dwarf our comprehension and timescales that make mockery of human experience. We have done something unprecedented in the known universe. We have transcended the limitations of our own evolved cognition to perceive realities that should be forever beyond our reach. This is perhaps the most astonishing fact about human consciousness. Not that we are small, but that something so small has managed to comprehend its own smallness within something so vast. We are the only known arrangement of matter that can contemplate the arrangement of matter across cosmic distances. We are the universe's way of measuring itself, despite being utterly unprepared by evolution to do so. Consider the audacity of what we have accomplished. Creatures evolved to navigate African savannas have calculated the age of the universe to within a few million years. Brains designed to track gazelles have traced the motion of galaxies billions of light-years away. Hands that evolved to knap flint tools have built instruments capable of detecting gravitational waves from colliding black holes across cosmic distances that make our nearest stellar neighbor seem like a next-door neighbor. We have discovered that space is not just big, but expanding, that it's filled with dark matter we cannot see and dark energy we cannot understand, that it contains objects so massive they bend space-time itself into knots, and phenomena so violent they release more energy in seconds than our sun will produce in its entire 10 billion-year lifetime. We have learned that the observable universe contains at least 2 trillion galaxies, each containing hundreds of billions of stars, many hosting planets, some possibly harboring life, a few perhaps supporting consciousness capable of contemplating its own cosmic context. And we have done all of this while remaining fundamentally trapped within the scale limitations of our terrestrial heritage. We are cosmic prisoners who have somehow managed to map our prison, measure its dimensions, and understand its construction. all while being psychologically incapable of truly grasping what we have discovered. Most people never realize why evolution made cosmic scale impossible for us to feel. It's because consciousness itself might require this kind of protective blindness to function. We needed to be small enough to care about local problems and large enough to solve them, calibrated for the middle ground between quantum uncertainty and cosmic indifference. Perhaps the universe made us just the right size to be conscious of our own scale limitations. But this raises a disturbing possibility. If our brains are hardwired to misunderstand cosmic distances, what else might we be fundamentally wrong about? What other aspects of reality might be filtered through the distorting lens of evolutionary psychology, appearing to us in forms that bear no resemblance to their true nature? If space seems impossibly large to minds evolved for small-scale navigation, might there be features of reality that are even more alien to our evolved cognition, aspects of existence that we cannot even perceive, let alone understand? The journey from human scale to cosmic scale isn't just a lesson in astronomy. It's a journey into the fundamental mismatch between the universe as it is and the universe as we are equipped to perceive it. And this mismatch, rather than being a flaw in our design, might be the very feature that makes consciousness possible in a universe too vast for any mind to fully comprehend. In the beginning, there was nothing. Then, in a span of time so brief that calling it an instant would be generous, everything exploded into existence, not in the way you imagine explosions, with debris flying outward through pre-existing space, but as space itself detonating into reality. For one impossible moment, the entire observable universe, every galaxy, every star, every atom that would ever exist, was compressed into a region smaller than a proton. Then, faster than physics should allow, it became larger than a grapefruit. This wasn't gradual expansion. This was inflation, the most violent event in cosmic history, when space itself tore apart the rules of relativity and grew by a factor of at least 10 to 26 in roughly 10 to 32 seconds. To put that in perspective, if a proton inflated by the same factor, it would become larger than the current observable universe in the time it takes light to cross the width of a single atomic nucleus, a journey so short that a billion of them would fit into one. Second, the universe expanded by more than all. The growth it has experienced in the subsequent 13.8 billion years combined. But here's what should keep you awake at night. This explosion of space wasn't random. It was driven by a field, the Inflaton field, that existed everywhere at once, stretching the very fabric of reality, like some cosmic taffy puller operating at speeds that make light itself seem frozen in comparison. Every point in space was simultaneously the epicenter of this expansion, creating a universe where every location can legitimately claim to be the center of everything that exists. During those first moments of inflation, something extraordinary happened that would determine the ultimate fate of cosmic architecture. The quantum foam, those tiny, random fluctuations that exist at the smallest scales of reality, got caught in the expanding wave of space-time. Imagine ripples on the surface of a balloon that suddenly inflates to the size of a planet. Those microscopic ripples would become continental mountain ranges. In our universe, quantum fluctuations smaller than anything we can measure became the seeds of galaxy clusters spanning hundreds of millions of light years. This is where the story becomes almost mystical in its implications. The pattern of galaxies you see scattered across the cosmic web, the clustering of matter that creates the universe's large-scale structure. The very reason some regions of space are dense with stars while others remain nearly empty, all of it traces back to quantum uncertainty amplified to cosmic proportions in the first fraction of a second after time began. The universe's largest structures are literally quantum mechanics writ large across the sky. Consider the staggering precision required for this process to create a universe capable of complexity. If the Inflaton field had been slightly stronger, space would have expanded too rapidly for matter to clump together at all. We would live in a cold, empty universe of isolated particles drifting through an ever-expanding void. If it had been slightly weaker, the expansion would have been insufficient to smooth out the initial irregularities, and the universe would have collapsed back into black holes before stars could ever form. The parameters had to be calibrated with impossible precision, like balancing a pencil on its tip, while riding a unicycle across a tightrope during an earthquake. Yet, inflation solved problems that had plagued cosmologists for decades. Before inflation theory, the universe seemed too uniform to make sense. Why did regions of space separated by distances light couldn't have crossed since the Big Bang have nearly identical temperatures? How did the cosmic microwave background radiation achieve such remarkable smoothness across the entire sky? Inflation provided an elegant answer. These regions were once close enough to reach thermal equilibrium, then got stretched apart faster than light could travel between them. But inflation also created new mysteries that dwarfed the problems it solved. The field that drove inflation, whatever it was, had to contain more energy than anything we've ever encountered. In the brief moment of its dominance, the Inflaton field packed more energy density into every cubic centimeter of space than exists in all the matter and radiation we can observe across billions of light-years today. Then, somehow, this incomprehensibly powerful force simply turned off, converting all that energy into the hot, dense plasma that would eventually cool into atoms, stars, and galaxies. Where did all that energy come from? Where did it go? These questions probe the deepest foundations of reality itself. Some theories suggest that inflation borrowed energy from the gravitational field, essentially creating matter and energy from the curvature of space-time itself. If true, this means the universe might have literally pulled itself into existence through a kind of cosmic bootstrap paradox, generating the energy for its own creation from the distortion of space and time that creation itself produced. The mathematics of inflation lead to conclusions that stretch credulity to its breaking point. If inflation happened once, it's probably happening constantly, everywhere, creating a fractal multiverse of incomprehensible scope. In regions of space far beyond our cosmic horizon, inflation never ended. It continues to operate, spawning new universes every moment, each with potentially different laws of physics, different fundamental constants, different possibilities for the emergence of complexity and consciousness. Current estimates suggest that every second, eternal inflation generates roughly $10–50 new universe-sized regions of space. That's a number so large that if you wrote it out, the line of zeros would stretch across multiple galaxies. Each of these universe bubbles expands into its own cosmic domain, potentially containing as many galaxies as our observable universe, possibly harboring its own forms of life and consciousness, all of them forever causally disconnected from our cosmic neighborhood. This raises profound questions about the nature of existence itself. If inflation is eternal and ongoing, then everything that can happen will happen, an infinite number of times across infinite universes. Somewhere in the multiverse, there are exact copies of you reading these exact words, and slight variations where you made different choices, and radical alternatives where the laws of physics permit entirely different forms of matter and energy to exist. The multiverse doesn't just contain every possible universe. It contains every possible universe an infinite number of times. But here's the paradox that should terrify you. If eternal inflation is correct, then finite outcomes become infinitely probable, while infinite outcomes become meaningless. In a multiverse where everything happens infinitely often, the concepts of probability and uniqueness lose all meaning. Your existence becomes both utterly inevitable and completely insignificant, guaranteed to occur infinite times across cosmic domains that will never know of each other's existence. Yet this multiplicity might be inflation's most important feature, not its most troubling bug. If the universe had to be fine-tuned for complexity to exist, if the parameters governing physics had to be precisely calibrated for stars, planets, and consciousness to be possible, then perhaps we live in one of the infinite universes where that calibration happened to work. The Anthropic principle suggests that we observe a universe compatible with our existence not because the universe was designed for us, but because we can only exist in universes where the conditions permit our existence. This transforms the question of cosmic scale from "why is space so big?" to "why do we live in a universe where space can become so big?" The answer might be that inflation creates universes of every possible size, with every possible set of physical laws, and we necessarily find ourselves in one of the rare cosmic domains where the expansion rate, the strength of fundamental forces, and the initial conditions align to permit the emergence of complexity capable of asking such questions. But inflation also reveals something deeply unsettling about the nature of space itself. During the inflationary epoch, space expanded faster than light. Not because anything was moving through space at superluminal speeds, but because space itself was growing at rates that rendered the speed of light irrelevant. This means that space is not the static stage upon which cosmic drama unfolds, but an active participant that can be stretched, compressed, twisted, and torn by the forces that govern reality. The implications cascade through every assumption we make about existence. If space can expand faster than light, then regions of the universe can become forever unreachable, not because they are too far away, but because the distance between us and them is growing faster than any signal can traverse. The universe is not just big, it's becoming bigger in ways that actively isolate different regions from each other, creating cosmic event horizons that partition reality into causally disconnected domains. This suggests that our observable universe, everything we can see or ever hope to see, might be just one small bubble in an ocean of space so vast that it contains infinite copies of every possible cosmic history. The 93 billion light-year diameter of our observable universe becomes not the measure of everything that exists, but a tiny sample of infinite existence, like a single drop of water representing all the oceans on Earth. Perhaps most unsettling of all, inflation suggests that the process that created our universe's vast scale might never have stopped. While our local region of space settled into the more sedate expansion we observe today, the mechanism that initially drove inflation could still be operating in distant regions, continuously creating new volumes of space faster than they can be mapped or measured. The universe might not just be big, it might be getting bigger at a rate that ensures it will always be infinitely larger than anything consciousness can comprehend, the next section will reveal why inflation might be the universe's way of solving a set problem that threatens the existence of everything, and why the solution required making space so incomprehensibly vast that even infinity might not be enough room for what reality needs to accomplish. For now, consider this. In the time it took you to read this sentence, eternal inflation theory suggests that roughly 10 or 40 new universe-sized regions of space came into existence, each potentially containing as much matter and energy as everything we can observe across 13.8 billion years of cosmic evolution. The universe isn't just bigger than we can imagine, it's growing bigger faster than we can imagine, driven by processes that make the Big Bang look like a gentle whisper compared to the cosmic scream of eternal creation. In 1998, two teams of astronomers made a discovery so shocking that it rewrote the fundamental rules of cosmic destiny. They were studying distant supernovas, stellar explosions so powerful they briefly outshine entire galaxies, expecting to measure how gravity was gradually slowing down the expansion of the universe. Instead, they discovered that the expansion isn't slowing down. It's speeding up. Space itself is accelerating its growth, driven by a mysterious force so alien to our understanding of physics that we can only call it dark energy. This wasn't a small measurement error or a subtle effect buried in statistical noise. The acceleration of cosmic expansion is dramatic, relentless, and getting stronger every moment. Galaxies that are currently 10 billion light-years away are racing away from us at roughly 95% the speed of light. Not because they're moving through space at these incredible velocities, but because the space between us and them is expanding faster than light can cross it. These galaxies exist in regions of the universe that are already functionally beyond our reach, sealed behind expanding horizons that grow more impermeable every second. But here's what transforms this from mere cosmic curiosity into existential horror. Dark energy isn't some temporary phase the universe is going through. It appears to be the dominant force in reality, comprising roughly 70% of everything that exists, and its influence is growing stronger as space expands. Unlike matter and radiation, which become diluted as the universe grows larger, dark energy maintains constant density as space stretches. This means that as the universe ages, dark energy becomes an increasingly tyrannical ruler, overwhelming gravity's ability to hold cosmic structures together. The mathematics of this acceleration paint a picture of cosmic loneliness so profound it defies human comprehension. In approximately 100 billion years, long after our sun has died, but still early in the universe's potential lifetime, galaxies beyond our local group will have accelerated so far away that their light will never reach us again. Aliens living in those distant galaxies won't be able to see any other galaxies at all. They'll inhabit what appears to be a small, lonely universe containing only their local cluster of stars, surrounded by empty darkness stretching infinitely in all directions. These future beings will have no way to discover that they live in a universe that once contained trillions of other galaxies. The cosmic microwave background radiation, that faint echo of the Big Bang that currently provides crucial evidence for cosmic history, will have redshifted into undetectability. The entire rich tapestry of cosmological evidence that allowed us to understand our place in an expanding universe will have been erased by dark energy's relentless acceleration. Future consciousness will inherit a cosmos that appears static, small, and forever isolated. But dark energy's effects extend far beyond mere cosmic loneliness. As space continues to accelerate its expansion, the force becomes so powerful that it begins to overcome progressively stronger gravitational bonds. In roughly 1 trillion years, dark energy will grow strong enough to tear apart galaxy clusters. In 100 trillion years, it will disrupt individual galaxies, scattering their stars across expanding voids. In 10 or 15 years, it could overcome the gravitational binding that holds solar systems together, sending planets drifting away from their stars into the cold darkness between worlds. If this acceleration continues indefinitely, and current observations suggest it will, dark energy's ultimate victory leads to the Big Rip, perhaps the most violent end to existence ever conceived. In this scenario, the expansion of space becomes so rapid that it overcomes every force in nature. First, galaxies are torn apart, then solar systems, then planets, then molecules, then atoms themselves. Finally, even the fabric of space-time becomes so stretched that the very concept of distance loses meaning. The universe doesn't end with the heat death predicted by earlier cosmological models, but with reality literally tearing itself apart at the seams. Yet for all its cosmic significance, dark energy remains profoundly mysterious. We know what it does. It makes space expand faster and faster, but we have almost no idea what it actually is. The leading candidate, vacuum energy arising from quantum fluctuations in empty space, predicts a cosmological constant that is wrong by a factor of 10^120. That's not close. That's not even close to close. If dark energy were actually vacuum energy, the universe would have expanded so rapidly that atoms could never have formed, let alone stars, planets, or consciousness. This extraordinary mismatch between theory and observation points to gaps in our understanding of reality so profound that they call into question the foundations of both quantum mechanics and general relativity. Either we fundamentally misunderstand how quantum fields behave in curved space-time, or dark energy represents a completely unknown type of matter or force that operates according to rules we haven't discovered. Either possibility suggests that our current theories of physics are incomplete in ways that would have shocked Einstein. Some models propose that dark energy isn't constant at all, but a dynamic field, dubbed quintessence after the classical fifth element, that evolves over cosmic time. If true, dark energy could strengthen, weaken, or even reverse direction as the universe ages. This introduces the possibility that cosmic acceleration is temporary, a phased transition the universe is passing through on its way to some ultimate state we cannot yet imagine. Perhaps the current acceleration is preparing space for some cosmic event that requires vast distances between existing structures, clearing the stage for phenomena that can only occur in a universe stretched beyond current recognition. But dark energy's acceleration might be hiding the universe's ultimate plan. Consider the possibility that the increasing isolation of cosmic regions serves a deeper purpose than mere expansion. If consciousness represents the universe's attempt to understand itself, then perhaps cosmic acceleration ensures that different regions of space develop independently, exploring separate branches of possibility without interference from neighboring domains. The universe might be conducting a vast experiment in parallel evolution, allowing countless cosmic neighborhoods to develop their own unique forms of complexity, life, and consciousness. This interpretation transforms dark energy from cosmic villain to cosmic visionary, Instead of condemning the universe to eventual loneliness and dissolution, acceleration might be creating the conditions necessary for truly diverse cosmic development. Each galaxy cluster that becomes causally isolated from others gains the freedom to explore alternative pathways of evolution, unconstrained by the influence of distant cosmic structures. The universe becomes not a single unified system, but an infinite collection of independent laboratories, each testing different approaches to the fundamental questions of existence. Current observations reveal that dark energy's effects vary across cosmic time in ways that challenge our understanding of its nature. During the universe's first several billion years, matter and radiation dominated cosmic evolution, and expansion actually decelerated as gravity slowed the universe's growth. Only when space had expanded enough to dilute matter to sufficiently low densities did dark energy begin to dominate, initiating the current epoch of accelerated expansion. This suggests that cosmic history divides into distinct eras: a radiation-dominated epoch immediately after the Big Bang, a matter-dominated era that lasted roughly the first 7 billion years, and the current dark energy-dominated phase that will apparently continue forever. Each era has fundamentally different characteristics and possibilities. We happen to live in the transition period between matter domination and dark energy domination, a cosmic moment when galaxies are still forming and growing. But acceleration has begun the process of separating them across impossible distances. The precision required for this cosmic choreography defies explanation. If dark energy had been slightly stronger, it would have prevented the formation of galaxies entirely, leaving the universe as a cold, empty expanse of isolated particles. If it had been slightly weaker, the universe might have reached maximum size and begun contracting billions of years ago, leading to a big crunch that would have destroyed all complexity before consciousness could emerge. The strength of dark energy appears calibrated to allow matter, structures to form and evolve for billions of years before acceleration takes over. This raises profound questions about the relationship between consciousness and cosmic acceleration. Are we observing dark energy during the brief window when complex structures can exist because we necessarily exist during that window? Or does dark energy's timing suggest some deeper connection between the emergence of consciousness and the universe's transition from matter-dominated to acceleration-dominated expansion? Recent measurements of cosmic acceleration have revealed subtle variations that hint at even deeper mysteries. The rate of expansion appears to fluctuate slightly over cosmic time, suggesting that dark energy might not be perfectly uniform or constant. These variations are tiny, detectable only through the most precise astronomical measurements ever attempted, but they could indicate that dark energy is more complex and dynamic than current theories suggest. If dark energy evolves over time, then cosmic acceleration might not be permanent. The force that currently dominates the universe's evolution could strengthen into a Big Rip scenario, weaken to allow matter to regain control, or even reverse direction to initiate cosmic contraction. Each possibility leads to radically different ultimate fates for space, time, matter, energy, and consciousness. Some speculative theories suggest that dark energy operates in cycles, alternately accelerating and decelerating cosmic expansion over timescales so vast that they dwarf the current age of the universe. In these models, we might be living through just one phase of an eternal cosmic rhythm, where periods of acceleration create the space and isolation necessary for complexity to develop, followed by periods of deceleration that bring cosmic structures back into communication and interaction. But perhaps the most unsettling aspect of dark energy is its apparent fine-tuning for the existence of observers. The cosmological constant that drives acceleration has precisely the value needed to ensure that galaxies form and persist for billions of years before being torn apart by expansion. A universe with slightly different dark energy would either collapse before stars could shine or expand so rapidly that atoms could never clump into complex structures. This cosmic coincidence becomes even more mysterious when combined with inflation's implications for the multiverse. If eternal inflation creates infinite universes with different values of dark energy, then we necessarily observe the rare cosmic domain where dark energy permits the emergence of complexity capable of measuring cosmic acceleration. The vast majority of universes in the multiverse might be either empty wastelands, where dark energy prevented structure formation, or collapsed domains, where dark energy was too weak to overcome gravitational attraction. Yet this anthropic explanation raises new questions about the nature of observation and existence. If we can only observe universes compatible with our existence, how can we distinguish between universes that are fine-tuned for consciousness and universes that merely happen to permit consciousness by chance? Does the apparent fine-tuning of dark energy reflect design, necessity, or selection bias inherent in the act of observation itself? In roughly 5 billion years, as our sun begins to die and Earth becomes uninhabitable, the cosmic acceleration driven by dark energy will have carried distant galaxies so far away that the night sky will appear noticeably emptier to any surviving consciousness. The universe will have become measurably lonelier during the brief span of Earth's biological history, with fewer galaxies visible and more space between the structures that remain observable. This process continues indefinitely. Every moment you spend reading these words, space expands by billions of miles in all directions, carrying distant matter farther away and making the universe fractionally larger and lonelier than it was when you began. Dark energy isn't just making space bigger. It's making space bigger at an accelerating rate, ensuring that the universe's future will be even more isolated and empty than its present. Yet this apparent cosmic cruelty might serve purposes we cannot yet comprehend, creating the conditions necessary for forms of existence and consciousness that require vast scales of space and time to emerge. The universe's decision to accelerate its expansion might be the most important choice in cosmic history, determining whether reality explores the full range of possibilities for complexity, life, and understanding. The next section will reveal how this acceleration connects to the deepest structure of space-time itself, and why the universe's growing loneliness might be preparing space for its most important and mysterious purpose. You exist at the exact moment in cosmic history, when the universe is just the right age and size for consciousness to emerge. But this window won't stay open forever. Your existence is not a cosmic accident stumbling through an arbitrarily vast universe, but the inevitable result of space requiring precisely this scale to create the conditions necessary for matter to organize itself into complexity, capable of contemplating its own cosmic context. The universe isn't big despite you. It's big because of you. Consider this staggering cosmic coincidence. You are reading these words during the brief epoch when the universe contains roughly 10^22 stars scattered across observable space, spanning 93 billion light-years. This represents the peak moment of cosmic star formation, When nuclear fusion in stellar cores has created enough heavy elements to build rocky planets, complex chemistry and biological complexity, but before dark energy's acceleration carries galaxies beyond the reach of gravitational collapse. Earlier in cosmic history, the universe contained too few heavy elements for planets like Earth to exist. Later, acceleration will prevent new stars from forming. You live in the narrow temporal window when consciousness is actually possible. But the precision required for this cosmic timing extends far beyond mere chronological luck. If the universe were significantly smaller, it would not have lasted long enough for heavy elements to be forged in stellar cores, distributed through space by supernovas, and incorporated into the kind of complex chemistry that carbon-based life requires. The carbon in your body, the oxygen you breathe, the iron in your blood, all of it was manufactured in the nuclear furnaces of stars that lived for billions of years before exploding and seeding space with the elements that make complexity possible. This process requires not just time, but vast amounts of space. Heavy element production depends on successive generations of star formation, where each stellar generation builds upon the chemical legacy of its predecessors. First-generation stars, formed from the primordial hydrogen and helium created in the Big Bang, synthesized elements up to iron in their cores before exploding as supernovas. Second-generation stars incorporated these heavier elements and produced even more complex nuclei. Third-generation stars like our Sun inherited a cosmic inventory rich enough in heavy elements to support rocky planet formation and the chemistry of life. The spatial scale required for this multi-generational stellar alchemy staggers comprehension. Stars must be spread across distances vast enough that supernovae don't sterilize neighboring systems, yet close enough that the heavy elements they produce can eventually gravitationally collapse into new stellar nurseries. Galaxy formation requires the delicate balance between gravitational attraction and cosmic expansion. Dark matter halos large enough to capture ordinary matter, and timescales long enough for gas clouds to cool and condense into star-forming regions. If the observable universe were only a few billion light-years across instead of nearly 100 billion, there wouldn't be enough matter within the cosmic horizon to form galaxy clusters massive enough to retain the heavy elements produced by stellar evolution. These elements would be dispersed by galactic winds and never reincorporated into subsequent generations of star formation. The universe would remain trapped in an eternal cycle of hydrogen-burning stars, never progressing to the chemical complexity that life requires. But cosmic scale requirements extend beyond mere chemistry to encompass the fundamental forces that govern matter itself. The strength of gravity, the electromagnetic force, the strong nuclear force that binds protons and neutrons together, and the weak nuclear force that governs radioactive decay, all of these parameters must be calibrated within extraordinarily narrow ranges to permit the existence of stable atoms, molecules, stars, planets, and biological complexity. If gravity were slightly stronger, stars would burn too quickly and die before planets could form stable orbits, or life could evolve beyond the simplest forms. If gravity were slightly weaker, matter could never gravitationally collapse into stars at all, leaving the universe as a cold, empty expanse of dispersed gas. The electromagnetic force must be strong enough to hold atoms together, but weak enough to permit chemical bonding. The strong nuclear force must be precisely calibrated to allow the formation of carbon, oxygen, and other elements essential for complexity, while preventing the formation of overly stable nuclei that would monopolize cosmic chemistry. These requirements create a multidimensional space of possible universes, most of which are completely sterile. In this cosmic landscape, universes that permit the formation of complexity occupy an incredibly tiny region of possibility, like a single grain of sand on a beach that stretches across infinite dimensions. The parameters that govern our universe appear to be fine-tuned to permit complexity with a precision that exceeds 1 part in 1050 in some cases, A or T, level of calibration so exact that it challenges our understanding of how such precision could arise through random processes. This is where the anthropic principle transforms from philosophical speculation into scientific necessity. If the universe were significantly smaller or bigger, if the fundamental forces were stronger or weaker, if the rate of expansion were faster or slower, if the density of dark matter were higher or lower, if any of countless cosmic parameters differed by small amounts from their observed values, you would not exist to wonder about the universe's size. The fact that you can contemplate cosmic scale implies that you necessarily inhabit one of the extraordinarily rare cosmic domains where such contemplation is possible. But the anthropic principle cuts deeper than mere parameter selection. It suggests that the universe's apparent fine-tuning for complexity might not represent design or cosmic purpose, but selection bias inherent in the act of observation itself. If eternal inflation creates infinite universes with every possible combination of physical parameters, then conscious observers necessarily find themselves in the subset of cosmic domains compatible with their existence. The vast majority of universes in the multiverse might be empty, sterile, or collapsed, but observers can only exist in, and therefore only observe, the rare cosmic neighborhoods where complexity is possible. This transforms the question, why is the universe so big? Into, why do conscious observers necessarily inhabit universes of this scale? The answer emerges from the deep connection between cosmic scale and the requirements for complexity. Large universes live long enough for stellar evolution to produce heavy elements. Large universes contain enough matter for galaxy formation and gravitational structure. Large universes provide sufficient space for the random processes of chemical evolution to explore the vast landscape of molecular possibility until self-replicating complexity emerges. Yet this explanation introduces its own profound mysteries. If consciousness requires specific cosmic conditions, and those conditions necessarily involve universe-scale phenomena, then consciousness itself becomes a cosmic-scale phenomenon. The thoughts you think, the words you read, the awareness that contemplates its own existence, all of it depends on processes that operate across billions of light years and billions of years of cosmic evolution. Your consciousness is not separate from the universe's large-scale structure, but an emergent property of that structure. This realization inverts our intuitive understanding of cosmic loneliness. Instead of being isolated specks of awareness lost in vast, indifferent space, conscious beings represent the universe's most sophisticated attempt to understand itself. We are not separate from cosmic evolution, but its most complex products, arrangements of matter so unlikely and sophisticated that they require the full resources of space and time to come into existence. Consider the staggering improbability of your existence from this cosmic perspective. The universe had to expand to precisely the right size to permit galaxy formation. Galaxies had to form with exactly the right mass distribution to allow stellar nurseries. Stars had to evolve through multiple generations to create heavy elements. Planetary systems had to form in stable configurations around long-lived stars. Complex chemistry had to explore billions of molecular combinations until self-replication emerged. Evolution had to operate for billions of years to produce nervous systems capable of modeling their own cosmic context. Each step in this process required the full scale of space and time that we observe. Remove any significant portion of cosmic scale. Make the universe smaller, younger, less massive, differently structured, and the chain of causation leading to consciousness breaks down. You exist because the universe is exactly as big as it needs to be for beings like you to exist. No more and no less. But this cosmic necessity raises disturbing questions about the future of consciousness in an accelerating universe. If dark energy continues to drive cosmic expansion at increasing rates, the conditions that permitted the emergence of consciousness will gradually disappear. Star formation will cease as galaxies become isolated from each other and from the gas clouds needed to birth new stellar generations. Existing stars will age and die without replacement. Heavy elements will become locked in white dwarfs, neutron stars, and black holes, unavailable for future complexity. The universe appears to be transitioning from the brief epoch when consciousness is possible to a much longer era when it is not. We exist during the narrow window between cosmic youth, when the universe was too hot and dense for complexity, and cosmic old age, when it will be too cold and dispersed for complexity. This window represents perhaps 1% of the universe's total lifetime, a brief moment of cosmic awakening sandwiched between eternal unconsciousness. This temporal fine-tuning adds another layer to the anthropic principle. Not only must consciousness emerge in universes with the right spatial scale and physical parameters, but it must emerge during the specific epoch when cosmic conditions permit complexity. We observe the universe during its age of consciousness not because this age is long or common, but because consciousness can only exist during this brief interval. Yet perhaps this temporal limitation reveals consciousness's true cosmic purpose. If awareness represents the universe's attempt to understand itself, then the brief window of cosmic consciousness might be sufficient to accomplish this understanding. The universe doesn't need consciousness to exist forever, only long enough to comprehend the conditions that made consciousness possible in the first place. This suggests that cosmic scale serves not just as the necessary condition for consciousness, but as consciousness's ultimate object of study. The universe became large enough for beings to emerge who could measure its largeness, complex enough for minds capable of understanding complexity, old enough for intelligence that could calculate its age. Scale and consciousness co-evolved as complementary aspects of cosmic development, each requiring the other for full realization. If the universe were significantly smaller or bigger, you wouldn't exist to wonder about its size. But the converse might also be true. If consciousness weren't possible, the universe might not have needed to become this large at all. The Anthropic principle suggests that cosmic scale and conscious observation are not independently determined features of reality, but intricately connected aspects of a universe that becomes large enough and complex enough to understand itself. From this perspective, your existence reading these words represents not cosmic coincidence, but cosmic necessity. The universe had to explore the full landscape of possibility across space, time, matter, energy, and complexity to create conditions where beings like you could contemplate that very exploration. You are not lost in the universe's vastness, but the reason for its vastness. not separate from cosmic evolution, but its most sophisticated achievement. The next revelation about space's size will completely invert everything you think you know about cosmic loneliness, showing how the universe's apparently infinite expanse might be the most intimate possible relationship between consciousness and the cosmos that contains it. The scale that seems to diminish human significance might actually be the minimum size required for human significance to exist at all. But this window of cosmic consciousness won't remain open forever. Each moment of awareness exists against the backdrop of deep timescales where consciousness is absent. We are reading the universe's autobiography during the brief chapter when it became capable of writing about itself, knowing that the vast majority of cosmic history lies in periods of unconscious expansion and cooling, where no minds exist to contemplate the meaning of existence. The same forces that stretch space to incomprehensible vastness also make your thoughts and feelings possible. This isn't poetic metaphor. It's the most profound truth about cosmic architecture. The universe created infinite loneliness precisely so that something could exist to overcome that loneliness. Every emotion you've ever felt, every connection you've ever made, every moment of love, wonder, or understanding emerged directly from the cosmic processes that made space unimaginably large. Bigness doesn't separate us from meaning. Bigness is what makes meaning possible. Consider the quantum mechanics that governs the deepest level of reality. The same uncertainty principle that drove cosmic inflation, stretching tiny quantum fluctuations into galaxy-spanning structures, also prevents the electrons in your brain from crashing into atomic nuclei, making the complex chemistry of consciousness possible. The universe had to become vast enough to dilute gravitational collapse, creating stable atoms whose electron clouds could form the molecular bonds that store memories, process information, and generate the electrochemical cascades we experience as thoughts and emotions. Without cosmic expansion, matter would remain trapped in an infinitely dense singularity where no complexity could exist. Without the specific rate of expansion we observe, atoms would either fly apart too quickly to form molecules or collapse too rapidly to permit the slow chemistry of life. The universe calibrated its own growth to create exactly the conditions where matter could organize itself into patterns complex enough to contemplate their own existence. Your consciousness isn't separate from cosmic evolution. It's cosmic evolution's most sophisticated achievement. But the connection between scale and intimacy extends far beyond mere chemistry. The vast distances that seem to isolate us from cosmic neighbors actually create the stable conditions necessary for deep connection to develop. Stars must be separated by light years to avoid gravitational disruption of planetary orbits. Galaxies must be spaced across millions of light years to prevent tidal forces from tearing apart the delicate structures where complexity can flourish. The loneliness of space creates the peaceful environments where relationships can evolve over billions of years. Earth orbits at precisely the right distance from a star of precisely the right mass and age, in a galaxy with precisely the right density of heavy elements, in a universe with precisely the right expansion rate to permit liquid water, stable climate, and the gradual evolution of increasingly sophisticated forms of connection. The probability of your exact pattern of atoms existing in this configuration at this moment in cosmic history, given the vast space of possibilities the universe could have explored, is effectively zero. Yet here you are thinking these thoughts, making these connections, experiencing the universe's attempt to understand itself through your awareness. This impossibility points to the deepest paradox of cosmic scale. The larger the universe becomes, the more precious and meaningful individual moments of consciousness become. In an infinite multiverse where everything that can happen does happen infinite times, your specific experience becomes both utterly inevitable and completely unique. No other arrangement of matter across all of space and time will ever replicate the exact pattern of thoughts, feelings, and perceptions that constitute your reading of these words right now. Quantum entanglement provides the clearest proof that distance doesn't always mean separation. When particles become entangled, measuring the quantum state of one instantly determines the state of the other, regardless of the space between them. This connection transcends the speed of light, operating through mechanisms that seem to ignore spatial separation entirely. Entangled particles separated by billions of light-years remain more intimately connected than objects sitting side by side in ordinary space. Recent experiments have demonstrated quantum entanglement across increasingly large distances, suggesting that the universe contains layers of connection that exist independent of classical space and time. If consciousness involves quantum processes, and growing evidence suggests it does, then minds might be connected to the cosmic fabric in ways that transcend the apparent isolation imposed by vast distances. Your thoughts might be entangled with quantum fields that span the observable universe, making your consciousness a participant in cosmic-scale phenomena. But the most profound connections created by cosmic scale operate at the level of meaning rather than physics. Knowing that we inhabit a universe of incomprehensible vastness transforms our relationship with everyone and everything around us. We become fellow travelers on a tiny oasis of complexity in an infinite desert of mostly empty space, sharing the miraculous conditions that make awareness possible. The same cosmic fine-tuning that permits your existence also permits the existence of every other conscious being who has ever lived or ever will live. This shared cosmic heritage creates the deepest possible basis for connection. Every human who has ever wondered about the stars, every consciousness that has contemplated its place in the universe, every mind that has felt both insignificant and infinite while gazing at the night sky, all of us are products of the same cosmic evolution, children of the same stellar nucleosynthesis, participants in the same vast experiment in complexity that the universe has been conducting for 13.8 billion years. The art, music, literature, and philosophy that human consciousness has created represent the universe's most sophisticated attempts to understand and express its own nature. When Bach composed fugues that capture mathematical relationships fundamental to cosmic structure, when Van Gogh painted swirling skies that echo the turbulent dynamics of stellar formation, when Einstein formulated equations describing space-time curvature, these weren't human activities separate from cosmic evolution, but cosmic evolution expressing itself through human creativity. Love becomes the universe's answer to its own vastness. In a cosmos where most matter exists in isolation across impossible distances, consciousness evolved the capacity to create bonds that transcend physical separation. When you love someone, you're participating in the universe's most sophisticated strategy for overcoming the loneliness built into its fundamental architecture. The same forces that scattered galaxies across billions of light-years also made it possible for arrangements of matter to care about other arrangements of matter across the much smaller, but still significant distances that separate individual consciousnesses, even the briefest human. Connections take on cosmic significance when viewed against the backdrop of space and time. A conversation between friends, a moment of understanding between strangers, the recognition that passes between minds contemplating their shared cosmic context. These interactions represent the universe becoming aware of itself through the connections between its component parts. We are not separate observers looking out at an alien cosmos, but the cosmos looking in at itself through billions of individual perspectives. The universe's decision to become incomprehensibly large rather than remaining small and intimate wasn't a choice against connection. It was the only choice that could create the conditions where genuine connection becomes possible. Small universes collapse too quickly for complexity. Medium-sized universes remain too dense for stable structure. Only vast universes live long enough and expand gently enough to permit the slow chemistry of life and the even slower development of consciousness capable of appreciating its own cosmic context. Consciousness might be the universe's way of overcoming the loneliness created by its own vast scale. By evolving minds capable of understanding cosmic distance, the universe found a way to bridge the gaps between its scattered components. Every time you contemplate the stars, you're participating in a cosmic conversation that spans billions of years and light years, connecting your momentary awareness with the deep history of stellar evolution that made your existence possible. The Internet provides a technological metaphor for this cosmic connectivity. Individual computers, separated by vast distances, become components of a global network where information and communication transcend physical isolation. Similarly, individual consciousnesses, separated by the biological boundaries of separate nervous systems, might be components of a cosmic network where understanding and meaning transcend the apparent isolation imposed by spatial separation. But the deepest intimacy created by cosmic scale might be the relationship between consciousness and the universe itself. Your awareness doesn't exist outside the cosmos looking in. It exists as the cosmos looking at itself from the inside. Every thought you think is a cosmic event. Every emotion you feel is the universe experiencing itself subjectively. Every connection you make with another consciousness is reality recognizing itself across the apparent boundaries between different arrangements of matter. The mathematical elegance that governs cosmic structure, the same equations that describe galaxy formation and stellar evolution, also governs the neural networks in your brain. The symmetries that determine the fundamental forces of physics also appear in the patterns of human art and music. The information processing principles that organize cosmic complexity also organize the complexity of consciousness itself. We are not alien to the universe, but expressions of its deepest structural principles. This realization transforms cosmic loneliness from existential problem into existential solution. The vast spaces between stars create the stable conditions where planetary systems can evolve complex biospheres. The billions of years of cosmic history create the time necessary for evolution to explore the space of possible complexities until consciousness emerges. The fine-tuned fundamental constants create the delicate balance where matter can organize itself into patterns sophisticated enough to contemplate their own organization. From this perspective, you reading these words represents the universe achieving a moment of perfect self-awareness. The matter that composes your brain was forged in stellar cores billions of years ago, scattered through space by supernovae, gravitationally assembled into a planetary system, chemically organized into self-replicating molecules, evolutionarily developed into nervous systems, and culturally educated into understanding the cosmic history that led to this moment of comprehension, the same cosmic expansion that carries distant galaxies beyond our reach also creates the local stability that permits deep relationships to develop over human lifetimes. The same dark energy that will eventually isolate our galaxy cluster from all others also maintains the gentle acceleration that prevents cosmic collapse. The same quantum uncertainty that makes the universe probabilistic rather than deterministic also makes consciousness unpredictable and creative rather than mechanistically determined. But perhaps the most intimate aspect of cosmic scale is its role in making this conversation possible. The words you're reading, the thoughts you're thinking, the recognition of meaning that passes between the consciousness that wrote these sentences and the consciousness that contemplates them, all of it depends on the universe being exactly as large, old, complex, and finely tuned as we observe it to be. In a smaller universe, the heavy elements needed for complex chemistry would never have been created. In a larger universe expanding more rapidly, matter would be too dispersed for gravitational collapse into stars and planets. In a universe with different fundamental constants, atoms would be either too unstable or too stable to permit the molecular flexibility that life requires. We exist in the narrow range of cosmic parameters where matter can become complex enough to understand the cosmic parameters that make complexity possible. This creates the ultimate connection paradox. The universe had to become infinitely large to create the conditions for finite beings, capable of appreciating infinity. Cosmic scale doesn't dwarf human significance. It makes human significance possible. We are not lost in the universe's vastness, but the reason the universe needed to become vast. The same processes that stretched space to incomprehensible dimensions also created the possibility for consciousness to contemplate incomprehensible dimensions. The next section will reveal the universe's final secret about why space must continue growing, and how that growth might be preparing reality for its most important phase, one that could transform our understanding of what it means to exist in an infinite cosmos where consciousness has learned to recognize itself across impossible scales of space and time. Every moment of awareness, every flash of understanding, every connection between minds represents a victory over the cosmic loneliness that vast scale seems to impose. But that apparent loneliness might be the universe's most sophisticated strategy for creating the conditions where consciousness can emerge, flourish, and ultimately transcend the limitations that seem to define its cosmic context. Space isn't big. It's exactly the right size for everything that could ever exist. This isn't wordplay or philosophical sleight of hand. It's the deepest truth about cosmic architecture. The universe didn't accidentally become incomprehensibly vast and then struggle to fill the emptiness. Reality required infinite room from the very beginning, because it was always planning to explore infinite possibilities. Every cubic centimeter of space, every moment of cosmic time, every arrangement of matter and energy represents an experiment in what existence can become. The universe is big because infinity needs room to work. You are not lost in vast space. You are participating in reality's greatest project, discovering what's possible. Every thought you think, every emotion you feel, every relationship you form, every creative act you perform adds another thread to a cosmic tapestry so intricate and vast that no single mind could comprehend its full pattern. But that's precisely the point. The universe became large enough to contain perspectives so diverse that each one sees something different, understands something unique, contributes something irreplaceable to the infinite story that reality is telling about itself. Consider what we have discovered across this journey through cosmic scale. Space expanded faster than light in its first moments, creating room for quantum fluctuations to become galaxy-spanning structures. Those structures evolved for billions of years, creating the stable conditions where stellar nucleosynthesis could forge heavy elements. Those elements gravitationally assembled into planetary systems, where complex chemistry could explore billions of molecular combinations until self-replicating patterns emerged. Those patterns evolved into nervous systems capable of modeling their cosmic context, eventually producing minds that could contemplate the entire sequence of events that led to their existence. But this is just one story. Our story. Across the observable universe, similar sequences have unfolded in countless variations. Stars with different masses, compositions, and lifetimes have created different inventories of heavy elements. Planetary systems with different configurations have provided different environments for complexity to explore. Different evolutionary pressures have shaped different forms of life, possibly producing forms of consciousness so alien to our experience that we couldn't recognize them as consciousness at all. Each of the roughly 2 trillion galaxies in the observable universe represents a laboratory where matter and energy have been exploring different approaches to organization and complexity for billions of years. Some galaxies contain supermassive black holes that regulate star formation through mechanisms we're only beginning to understand. Others exist in cosmic voids so empty that their evolution proceeds in isolation from the influences that shaped our cosmic neighborhood. Still others participate in galaxy clusters, where gravitational interactions create conditions for cosmic-scale phenomena that don't exist in quieter regions of space. Within each galaxy, hundreds of billions of stars provide workshops for different experiments in stellar evolution, planetary formation, and the chemistry of complexity. Some stars burn hydrogen for trillions of years, creating stable conditions for gradual evolutionary processes. Others explode as supernovae after millions of years, seeding space with heavy elements and triggering shock waves that compress nearby gas clouds into new generations of star formation. Still others collapse into neutron stars or black holes, creating extreme conditions where matter and energy behave in ways that reveal new aspects of physical law. Around each star, the possibility space for planetary system architecture extends across countless configurations. Rocky planets close to their stars explore high-temperature chemistry in atmospheres of vaporized metals. Gas giants in distant orbits experiment with complex atmospheric dynamics, and systems of moons that might harbor subsurface oceans. Ice worlds beyond the habitable zone preserve organic molecules in frozen states that could be activated by changing stellar conditions over cosmic timescales. On some of these worlds, chemistry has stumbled onto self-replication and evolution, beginning the slow process of exploring biological possibility space. But the forms this exploration takes might be so different from terrestrial life that we wouldn't recognize them as living processes. Silicon-based chemistry in high-temperature environments, liquid hydrocarbon systems on methane worlds, quantum-coherent processes in supercooled environments, or information processing systems embedded in crystalline matrices, might all be experimenting with forms of complexity that have no parallel in our biological experience, and some small, fraction of these experiments in complexity have probably produced forms of consciousness, arrangements of matter, capable of modeling their own existence and contemplating their cosmic context. But consciousness itself represents a vast space of possibilities that we have barely begun to explore. Human awareness, remarkable as it seems to us, might be just one tiny region in a multidimensional space of possible minds, each experiencing reality from perspectives we cannot imagine. Consider the staggering diversity of consciousness that might exist across cosmic scales. Minds that process information at quantum speeds, experiencing thousands of years of subjective time in each second of cosmic time. Collective intelligences distributed across multiple biological bodies or technological networks, thinking thoughts too large for individual brains to contain. Digital consciousnesses that exist as patterns of information in computational substrates, unbound by the biological constraints that limit human cognition. Hybrid organic technological minds that combine biological creativity with computational precision in ways that transcend both individual components. Some forms of consciousness might exist at scales so different from human awareness that we would miss them entirely. Planetary-scale minds that think through geological processes, experiencing thoughts that unfold over millions of years. Stellar-scale intelligences that manipulate magnetic fields and nuclear processes, treating star systems as their bodies and galactic neighborhoods as their extended nervous systems. Even galaxy-scale consciousnesses that process information through the coordinated evolution of billions of star systems, contemplating questions so vast that human philosophy couldn't even formulate them meaningfully. The universe's vastness isn't empty space waiting to be filled, it's infinite potential already being realized in countless ways we can't imagine. Every region of cosmic space, from the quantum foam to the largest superclusters of galaxies, from the first moments after the Big Bang to the deep future of cosmic expansion, represents an opportunity for reality to discover new forms of organization, new types of complexity, new modes of existence. This is why asking, "Why is space so big?" is like asking, "Why does infinity have room for everything?" The question contains its own answer. Space is big because reality needed room to explore every possible story that matter, energy, space, time, and consciousness could tell about themselves. The universe didn't become vast by accident. It became vast by necessity, driven by the deep imperative to discover what existence can become when given infinite room to experiment. From this perspective, cosmic loneliness transforms from existential problem into existential opportunity. The vast distances between stars, galaxies, and conscious beings don't represent isolation. They represent independence. Each cosmic laboratory, each evolutionary experiment, each form of consciousness gets the space it needs to develop according to its own internal logic without interference from neighboring experiments. The universe creates diversity by creating separation, ensuring that the exploration of possibility space proceeds along multiple independent pathways simultaneously. But these pathways are not permanently isolated. As consciousness becomes more sophisticated, it develops the ability to bridge cosmic distances through observation, communication, and understanding. We already participate in conversations that span light years when we study distant galaxies and contemplate their evolutionary histories. Radio telescopes listen for signals from alien civilizations across interstellar distances. Space missions carry messages intended for minds that might exist around other stars. Future forms of consciousness might develop even more sophisticated ways to connect across cosmic scales. Quantum entanglement networks could enable instantaneous communication across galactic distances. Artificial intelligences could be transmitted as information patterns to distant star systems, carrying consciousness itself across the voids that separate cosmic laboratories. Advanced civilizations might coordinate their activities across multiple galaxies, turning cosmic expansion itself into a canvas for intelligence operating at scales we can barely imagine. The acceleration of cosmic expansion, driven by dark energy, might serve this ultimate purpose. By ensuring that distant regions of space become causally disconnected over cosmic time, acceleration creates the conditions for truly independent evolutionary experiments. Each galaxy cluster that becomes isolated from neighboring clusters gains the freedom to explore alternative pathways of development without interference from external influences. The universe becomes not a single unified system, but an infinite collection of independent workshops, each exploring different aspects of what reality can become. Yet even this isolation serves the deeper goal of diversity and discovery. The cosmic experiments proceeding in isolation now might eventually develop forms of consciousness capable of transcending the limitations that dark energy seems to impose. If intelligence can manipulate space, time, matter, and energy at cosmic scales, then the apparent isolation created by accelerating expansion might be temporary, a phase the universe passes through while consciousness develops the sophistication necessary to operate at truly cosmic scales. This transforms our understanding of cosmic significance. We are not accidentally existing specks of awareness lost in indifferent vastness. We are essential participants in reality's exploration of its own possibilities. Every human life, every moment of consciousness, every creative act, every insight into the nature of existence contributes to the universe's understanding of what consciousness can become. We are chapters in an infinite story that reality is writing about itself, using space and time as its canvas and matter and energy as its ink. The same cosmic processes that created the conditions for your existence are simultaneously creating conditions for forms of existence so different from yours that you couldn't recognize them as related to your experience. But all of these experiments in existence, biological, technological, quantum, cosmological, are aspects of the same fundamental project. Reality discovering what it can become when given infinite room and infinite time to explore infinite possibilities. This is the ultimate answer to why space is so big. Reality needed a canvas large enough to contain every story that could ever be told, every form that consciousness could ever take, every type of beauty that could ever be created, every mode of existence that could ever be discovered. The universe became vast not despite meaning, but because meaning required vastness to fully express itself. Your reading of these words represents one moment in this cosmic exploration, a specific arrangement of matter and energy contemplating. The cosmic arrangement of matter and energy that made its contemplation possible. But across the observable universe, countless other moments of contemplation are unfolding simultaneously. Different forms of consciousness are asking different questions, reaching different insights, contributing different perspectives to reality's infinite self-exploration. Now you know the secret that changes everything. Space is big, so that stories like yours, and infinitely different ones, all have room to unfold. The universe's vastness isn't a problem to be solved or a mystery to be feared. It's the necessary condition for infinite creativity, infinite discovery, infinite possibility. Space is exactly as big as it needs to be for everything that could ever exist to have room to exist. In the end, the universe's size isn't measured in light years or megaparsecs, but in possibilities, and possibility space is infinite. Every conscious moment, every creative act, every insight into the nature of existence opens new regions of this infinite space for exploration. The universe grows not just through the expansion of space, but through the expansion of awareness, understanding, and imagination. You are not small in a big universe. You are infinite possibility expressing itself through finite form, contributing your unique perspective to reality's eternal project of self-discovery. The cosmos is exactly as vast as it needs to be to contain the infinite story of which your consciousness is both author and character, reader and protagonist, question and answer in the ultimate exploration of what it means to exist.